This is AP Calculus AB. We are on worksheet 4-9, triangular related rates. The only thing that you need to remember for this entire worksheet is the Pythagorean theorem and then its derivative, and we can solve every single problem. I know that the last two problems on this homework are particularly difficult because it does not rely on Pythagorean theorem, but the general theme of related rates, which is to set up an equation, take the derivative, and solve. In number one, we have a 13-foot ladder sliding down a vertical wall. I immediately want to start drawing a picture of this one. So I try to make my pictures as small as possible because we don't have a lot of room here. So I'm going to make a right triangle, and it is indeed a right triangle. It's a 13-foot ladder, so if I'm going to call things, I have an A. I don't know if I have enough room if I put an A here. Let me move my A. Whoa, that eraser is too big. Let me move my A over here. My B here. That gives me room to do the derivative. So C prime will go here, a B prime will go here, an A prime here. We have a 13-foot ladder, which means our C is 13 feet, and usually ladders don't change in length, so that means C prime is going to be 0. What else do we know? It's going down a vertical wall. So when I see the word down, I interpret that as a negative word. I mean, it's positive would have gone up. So that rate is 12 feet. So that's an A prime is a negative 12. So I'm going to put a negative 12 over here. What else do we have? When the top of the ladder is 5 feet from the ground. So 5 feet up from the ground means A is a 5. What is the rate of change of the distance between the ladder and the wall? So I'm looking for a B prime here. That's our unknown. And generally the way that we solve each of these problems is we need to solve for every single one of these variables except for this one. So I first need to find a B, and then I'll be able to find a B prime. So to find this B, I'm going to use the normal Pythagorean theorem. So let me draw a second triangle over here. And this one is without calculus. So if I just have a triangle with lengths of 5, 13, and B, the question is, what is B? And you might remember your special right triangles. There's really 3 that you should know for all of calculus and all of math, really. And let me draw them right now. So your special right triangles that you should know these 3. And I don't know if I have enough room here to do them all, but I'm going to try. Okay, so you have your 3, 4, 5, and then if you double that, you get a 6, 8, 10. Those are the first 2 that you have to have memorized. The other one that's really nice to know is the 5, 12, 13. And this is one of those cases where it's a 5, 12, 13. But let's go ahead and say, I don't know how to do that, Mr. Sindel. I haven't memorized all of my Pythagorean triples. Well, then you can just plug this into the Pythagorean theorem, which is a squared plus b squared is equal to c squared. And I will prove to you that b is indeed 12. So let's go ahead and say 5 squared plus b squared is equal to 13 squared. 25 plus b squared is equal to 169. And then b squared is equal to 144, and then finally b is equal to plus or minus 12, but it doesn't make sense to have a minus 12, so we'll just say a positive 12. So again, b is 12, and that comes from our Pythagorean triple up here. I think if I move all these triangles up, then it won't be smushed into this problem so much. Cool. All right, so we have b is equal to 12, so we can plug that in. We can now say that b is 12 over here, and we can solve for the Pythagorean theorem with our derivatives. So just as a reminder, when we take the derivative of the Pythagorean theorem, we get an equation which we simplify. So the unsimplified equation is 2a prime plus 2b b prime is equal to 2c c prime. If we divide everything by 2, we get a prime plus b prime is equal to c prime. This is kind of the gold standard that we're going to be using over and over again without the 2's, and that's the one I'm going to be plugging into as well. So let me set this up. I have an a prime plus b prime is equal to a c prime, and then from here I'm going to plug everything in. So I need to see my triangle. I have a 5 times a negative 12 plus, and then that was the 12 that we just figured out over here, and maybe I can do that one here to make this a little bit easier. I'm going to change all of these to blue so we can see what's going on here. Do I have the correct shade of blue? I think that's more or less the right shade. And then from here I'm going to say this is times b prime, which I don't know, so b prime, and that's going to be equal to c prime, which is 13 times 0. If I'm doing a little bit of math, 12 times 5 is 60, so I have a negative 60 plus 12b prime is equal to 0. And if I'm going to add 60 to both sides, I get 12b prime is equal to positive 60, and then divided by 12 gets you back to 5, right? B prime is equal to 5. So here's our answer, 5, and it is a b prime, which means it's a rate. So 5 what? It's feet per minute, I believe, because it says a rate up here. The rate is feet per minute. So we'll say our final answer is 5 feet per minute, and we'll box that. All right, let's try number 2. Again, another ladder. Let's go ahead and immediately draw a picture. Make sure we have enough room for all of our variables. So, boom, right triangle, go. And we have a right triangle. I'm going to go ahead and say I have an A prime. It doesn't matter where A and B go. I can switch them and I still get the same answer. Whoa, I was about to draw an A there. B prime and a C prime. These are all, this is kind of like a scavenger hunt, right? 5-foot ladder, so C is equal to 5, and therefore C prime is going to be equal to 0. And it's sliding toward the floor. Okay, so toward the floor, it's kind of hard to think about it, but toward the floor is going down, which means that is our negative number. The foot of the ladder is sliding away from the base of the wall at a rate of 6 feet per second. So this is our B prime from the last problem. We're trying to find the 5 in the last case, but now it's 6. So it tells us, hey, B prime, we know you're 6, and I'm considering that to be a positive number. So if it's away from the base of the wall, it's going in this direction, that's going out this way. I consider that to be a positive direction and left to be a negative direction. It's just kind of arbitrary, but that's what I'm going to go. And I consider up to be a positive and down to be negative, which is less arbitrary, but still, it's good to note. So we have 6 feet per second, and we're looking for the speed of the ladder sliding down. So now we're looking for an A prime. So I'm going to say A prime, that's equal to our box. That's the thing that we're trying to solve for. And the top of the ladder is 3 feet from the ground, so that's an A is equal to a 3. And again, we don't have a B. So let's go ahead and solve for B using this other triangle with normal Pythagorean theorem. So I have a triangle over here that's 3B 5, and if you've remembered your Pythagorean triple, which I'm going to just use from now on because it's going to be that much easier, this is a 3, 4, 5 triangle, and it's this one right here, 3, 4, 5 triangle. Again, these 3 and 4s can be interchanged, 6 and 8 can be swapped, 5 and 12 can be swapped, but the hypotenuse is always 13, hypotenuse is always 10, hypotenuse is always 5. So I'm going to use, I'm just going to make a note here in case people only look at the static answer key. I'm going to say this is a Pythagorean triple, which you have to have memorized. Therefore, B is equal to 4. Okay, now that I know B is equal to 4, then I plug it all into our formulas, which is A prime plus B prime is equal to C prime. All right, our scavenger hunt here is almost complete. A is 3, A prime we don't know, plus B, which we plugged in to get 4. B prime is 6 from the problem, so 4 times 6. And this is going to be equal to C prime, which is 5 times 0. 5 times 0. And what is that going to give us? So I have a 3A prime plus 6 times 4 is 24 is equal to 0. Let's subtract the 24, and I'm going to get 3A is equal to a negative 24. Divide both sides by 3, and A is equal to a negative 8. And does the negative make sense? Well, it does to me, right? Because I said going down is a negative number. So I'm going to say our answer here is a negative 8, and then this is, I made a slight typo. If you caught it, you can log the extra credit. This is an A prime. I don't know why I randomly got rid of this A prime, but we should be solving for an A prime, which is a rate. This negative 8 should be a rate, so it's going to be negative 8, and this is going to be feet per second. I'm just looking at another rate over here, feet per second, right? Feet per second. And then I can box that. Again, I typically stay away from boxing over here because it doesn't really make sense to box the A prime, because what if someone decided to call that X? What if someone decided to call that theta? It doesn't really make sense, but yeah, you don't usually box the variable name, you just box, hey, here's the answer, make sure we have the correct units, etc., right? All right, number 3, the top of a 25-foot ladder. Okay, another ladder problem. Let's go ahead and make a triangle. Here we go. So triangle, Good job. All right, so it's going to be a right triangle. Just have a feeling we're going to have a second triangle, but we'll go ahead and just leave this for now. B, we don't know. B prime, we don't know. A, we don't know yet. A prime, C, and C prime. Okay, scavenger hunt, go. 25-foot ladder, therefore 25 is C, and I'm guessing the 25 is not changing, so C prime is 0. It's sliding down, so that's a negative word. A vertical wall, and that's a rate of 3. So I'm going to say that's -3 for A prime, -3 for A prime. When the top of the ladder is 7 feet from the ground, so top of the ladder is A, so it's 7. What is the rate of change of the distance between the bottom of the ladder and the wall? So again, bottom of the ladder and the wall is this B prime, and yet again, we do not have a B. This is the third problem in a row where we're trying to solve for B. This is a case where this is not one of the Pythagorean triples, and we actually have to use the Pythagorean theorem, which is probably why we gave so much room for number 3 compared to the last problem. So let's go ahead and set up another right triangle and say, okay, in this triangle, it is a right triangle, and we have lengths 7, B, and 25. And I have a feeling the answer is going to be 24. I just kind of remember that Pythagorean triple. Let's see if Mr. Sundell is correct. So I'm going to set up Pythagorean theorem. I'm going to say, yes, A squared plus B squared is equal to C squared, and therefore 7 squared plus B squared is equal to 25 squared. Holy moly. If you don't remember, 25 squared is 625. And then this is going to be 49 plus B squared. Subtracting 49, B squared is going to be equal to, what is that, 576, right? 576, and I happen to know the square root of 576 off the top of my head. It's 24. So B is equal to plus or minus 24. Doesn't make sense for it to be a negative, though. You always have to do plus or minus whenever you take the square root. All right, so B is 24. And if you don't know how to square 25, you can always do it the long way. If you don't know how to do the square root of 576 off the top of your head, you can kind of guess and check it. I mean, last digit times last digit, 4 times 4 is 16, so it has to end in a 6. That was kind of a key giveaway for me, and then I remembered that it was 24. Let's keep filling in. All right, we have A prime plus B prime is equal to C prime. And from there, what do we have? So scavenger hunt was 7 and a -3. 7 and a -3. B was 24, and that's the number we found in blue, right? B prime, we don't know. That's what we're solving for. And that's equal to 25 times 0. And at this point, you might ask, will the ladder length ever matter? And the answer is no. The ladder length never really does matter, aside from it's useful for the Pythagorean theorem over here. But in terms of our calculus, nothing really happens, right? I have a -21 plus 24 B prime. That's equal to 0. Adding the 21 over gives us a 24. B prime is equal to a positive 21. Dividing both sides by 24 gives us a B prime, which is equal to 21 over 24. We can divide the top and bottom by 3, and I think that's going to turn into 7/8. Does it make sense that we are positive in this case? Let me just double check here. B prime is sliding away from the wall because we're sliding down with our ladder, so that's my positive direction in my head, so 7/8 is positive. Excellent. All right, so over here, I'm going to say and interpret my answer, 7/8, and then what is my rate? This is a B prime, so it is a rate. Do I have units here? It's feet per minute, so I'm going to come here and say this is feet per minute for my final answer, which I will then box. Excellent. All right. And this is the question where some people ask, well, should I convert this to a decimal? On these questions for this entire worksheet, you shouldn't have a calculator. I know it's tempting to use a calculator to find the square root of 576 and things like that, but every single type of problem on here is very similar to what you'll be doing, which is on the AP test, which is a free response question, and you don't have a calculator typically on these types of problems. All right, number 4. Okay, finally not a ladder. We have 2 cars. They're starting in the same place, so usually that same place in my mind is like on the corner of a right triangle, and then you're going to be traveling 2 different directions. That's what I'm going to guess. One car travels west, so west is like, I'm going to think of that as left, and the second car travels south. So left and south is going to be down, so I'm going to go left and down. Let's go ahead and make, we'll say we have a point right here, and we're going to go, one car is going to go down. Ooh, that was a not so great line. Here, I'm just going to move the point, haha, and then no one will know that I can't draw because I have technology to save me. Okay. Ooh, terrible arrow there. Still terrible, but we're going to go with it. So that's my diagram. The one going west, so I'm going to call these things A and A prime. I feel like I'm squished in here too much, so I'm moving you guys down a little bit. Now I have room to write. I have an A and an A prime. Ooh, tons of room to write. I have a B and a B prime. And I'm guessing there's like this imaginary distance in between them, which I'm going to call C and C prime. All right, so what do we got here? Let's fill in. We have west is a velocity. Okay, velocity is a word that means prime. It's a speed. It's a rate of change. So that's 50. 50 west. So it's going to go 50 miles per hour. That's an A prime. And the second car travels south at a velocity of 60 miles per hour. So I'm going to call this thing 60 miles per hour. How fast is the distance between them changing? And so that's going to be a C prime that we're looking for. If we find C prime, we're done. And it seems like we don't have enough information. We are missing a B, C, and an A, but then it tells us that the distance between them is changing 1/2 hour later. So 1/2 hour means that in this case, my time is going to be equal to 30 minutes, but since everything is in miles per hour, I'm just going to say 0.5 because that's hours. And we're using this second equation, which is to find distance, that's going to be equal to rate times time. So specifically, to find the distance for A, that's, I guess, A right here, that's the distance for A. I'm going to do the rate of A times the time that we have. So that, and I'm just going to switch that into, instead of distance of A, I'm going to say, that's A. A is equal to, I don't know why I'm saying distance here, I'm going to erase that. Will be confusing for the static answer key. A will be the rate of A times the time. So the rate of A is 50 times the time is 0.5. So therefore half of 25 is, or half of 50 is 25. Brain got too fast there. And I'm going to do the same thing with B. So B is going to be equal to 60 times 0.5. And therefore B is going to be equal to 30. And maybe I should change those to a secondary color so it makes sense for the static answer key. I'm going to say all of these were a second step, so let's make all of that black. And then I can come up here and say, okay, that was one of the steps, which means A is 25, and B was 30. So we got that from the black step. All right, so the only thing that I have on my list of scavenger hunt list, I guess, is C. If I find C, then I can find C prime. So how am I going to find C? And you'll probably guess it. It's Pythagorean, it is a Pythagorean triple, but we're going to use Pythagorean theorem, 25 and 30 and what? All right, so here we go. I'm going to do a triangle over here, and I'm going to make it, whoa, that was a terrible triangle. Slightly better. Technology saved me. Oh, technology, why? You failed me. There we go. I have a 25, 30, I want to make this 3 a little bit better, 30 and C. So how am I going to find that? And the answer is Pythagorean theorem. So I want to conserve space here. I haven't even got to the calculus yet. So I'm going to say A squared plus B squared is equal to C squared. These numbers are too big. I don't like them. So I'm going to convert this problem into an easier problem. And I'll just remember that I'm dividing by 5, and I'm going to make it into a tinier triangle. Oh my God, my right triangles when I draw them this direction are just not good. Okay. If I divide by 5, this is a 5, 6 something triangle. So that's the triangle. And then I'll just remember that when I solve for, I'm going to call this C1, this is going to be C2. To get from C2 to C1, I just need to multiply by 5 to undo this division by 5. So how do I do that? I'm going to plug you in. I'm going to say 5 squared plus 6 squared is equal to C2 squared. And then that's going to be 25 plus 36 is equal to still that C2 squared. And 25 plus 36 is 61. 61 is equal to C2 squared. And then I have this, this is gross. C2, we finally found, was the square root of 61. That's technically plus or minus the square root of 61, but Distance is always positive, so we exclude the negative. All right, well, to get from C1 or C2 to C1, we need to multiply by 5 to get to C1, and C1 therefore is 5 root 61, and 61 is a prime number the last time I checked, which means we can't really reduce it any more than that. Gross. Okay, well, 5 root 61, and here I am being called a liar because I don't know how I'm supposed to solve this problem without a calculator. Let's go ahead and try it. I think it's going to be hard, but I think we got it. So we found it. It's 5 root 61, 5 root 61, and from there I'm going to plug everything into the Pythagorean theorem. Let's just use another color here. I'm feeling colorful today. So I have an A prime plus B prime, well, my B's, is equal to a C prime. So A and A prime, holy moly, this is going to be a giant multiplication problem. 25 and 50. So this is 25 times 50. Maybe I should color code that all what it used to be. So it used to be red. So 25 times 50 plus B, which we found, if I'm color coding this, the 25 should have been black, huh? I care. I'm going to change you to black. 25 times 50 plus B was 30 and 60, I think. So it's going to be 30 times 60, and that's going to be equal to C, which we found was blue, right? C was this 5 root 61, disgusting. 5 root 61 times the thing that we're looking for, C prime, right? All right. C prime should be red because that was the original color. All right. Now I'm going to ignore the colors, and I'm just going to go with green. All right. 25 times 50. Well, that's 25 squared times 2. So 25 squared is 625. 625 times 2 is 1,250. So I'm going to say this is 1,250 plus 30 times 60 is the same thing as 30 times 30 times 2. 30 times 30 is 900. 900 times 2 is 1,800. 1,800. And that's going to be equal to that 5 root 61 of C prime. All right, so far so good. Adding the thousands, I'm going to get 3,050. 3,050, and that's going to be equal to 5 root 61. Disgusting. I don't like square roots in my answers. 5 root 61 C primes. And then I'm going to divide both sides by 5 root 61, and I'm going to get 3,050 divided by 5 root 61, and that's going to be equal to C prime, and I think 3,050 is divisible by 5, so we can cross cancel you. Dividing by 5 is the same thing as dividing by 10, which is getting rid of a 0, and then multiplying this number by 2. So 305 doubled is 610, so I believe this number should be 610 divided by root 61, and that's going to be equal to C prime, which, I mean, is done, but that's a radical that is in the denominator. That's you typically have to rationalize the denominator. So to do that, we are going to multiply both the top and bottom here by root 61. So times root 61 times root 61. So that's rationalizing the denominator, and we get our final answer, which is equal to, we'll do this in dark green here, C prime is equal to 610 root 61 all over 60. Oh, wait a second. Now, these numbers can be reduced. I can divide both top and bottom by 61, and this is going to turn into a 10 on the top. So let me do an arrow to indicate that I've switched directions. I'm going this direction. This is equal to 10 root 61. So this is 10 root 61. Whew. All right. Well, I don't like the square root in my answer, but there it is. So I'm going to write my final answer somewhere down here and interpret that. So it's going to be 10 square root of 61 what? 61, and this is a C prime, so it's a rate, and it's miles per hour. So I'm just going to say in pen though, oh my goodness, miles per hour, and then that is what I'm going to box. Whew, that one was tricky. I wanted to use a calculator there because I saw a square root, but I resisted the temptation. All right. Number 5, a railroad track and a road cross at right angles. Lucky for us, right angles is going to make a right triangle probably. An observer stands on the road 70 meters south of the crossing and watches an eastbound train traveling 60 meters per second. Okay, so let me see if I can do an illustration here. We have a train that's traveling east, so that's going to look like this. So an eastbound train, it's starting here and it's traveling east, so east to me is to the right. And then the observer is standing 70 miles south of the crossing. So I think the crossing is going to happen right here. So 70 miles south of the crossing. I think the observer is like down here, and the observer is facing this direction. I think that's what's happening. So let me go ahead and give myself some room here to analyze this diagram. So if the road is 70 meters to the south, I'm going to call this distance A, therefore A prime, B and B prime, and then this imaginary distance here, I'm going to do it as a dashed line. That was a terrible dashed line. I can try it a little bit better. All right. And there should be some right angle up there. This is going to be called our C and our C prime. All right, let's figure out what each of these is. I think I have the diagram correct. I might have to change this later. An observer stands on the road 70 meters to the south, so this distance here is 70 of the crossing, and watches the eastbound train traveling 60 meters per second. So B prime is 60, that's the train up here. How many meters per second is the train moving away from the observer? Oh, so the diagram is a little bit wrong. 4 seconds after it passes the intersection. Okay, I apologize that I have made a mistake. Really what I need to do is this. I'm going to restart because this diagram, as I predicted, was incorrect. So what's really happening is the train has already passed the observer. It wasn't clear from the very beginning. And the observer is right here. And it was looking at the train up here. And this distance right here, let me make the dashed line good from the very get-go. So this distance right here is going to grow farther and farther, and this is our supposed right triangle, though it kind of looks like an obtuse triangle. We're going to go ahead and just slap that symbol on it. Haha, now it's a right triangle. You have no say in the matter. All right. So we have an A, and an A prime. We have a B and a B prime, and a C and a C prime. Okay, just got to fill in each of these. So A prime we already said was 60, it's traveling away. B is 60 meters. I don't think the observer is moving, so I think our B prime here is 0. We're looking for how many meters per second is the train moving away. That's a C prime, so that's what we're looking for. And that's 4 seconds. Okay, so we know that time here is equal to 4 seconds. And we seem to be missing some stuff. I need like an A or a C or something. Oh, okay, we can find an A because we know a speed and we know a time, and I know this handy-dandy formula that tells me distance is equal to rate times time, which means in order to find A, the distance of A, will be the rate of A, which in this case is 60, times the time, which we know is 4 seconds. Luckily, the units do cancel out here. And this is another note that I should make in all of AP Calculus. They never try to mix the units. Like, this is seconds, this is seconds. They won't do, like, meters per minute and give you seconds here and make you convert this to minutes. I've never seen that before, but I guess it could happen in the future. I strongly doubt that. They're not trying to trick you. They're just testing your ability to solve math problems and use calculus. So if A is equal to 60 times 40, or times 4, not 40, is equal to 6 times 4, which is 24. Add on the 0, 240. Okay, and then from there we should be able to find that C. Okay, so this is the only piece of information that we need to solve for in order to solve for C prime. So right now I'm trying to find C. The way that I'm going to do that is with a just a right triangle, right? So I have a right triangle that looks like this, and I know that I have 240, which is a distance over here. I have 60, which is a distance over here, and I have C. Notice that that triangle is way too big, so I'm going to change this. I can divide everything by 60, I think. I mean, I can divide 24 by 6, and therefore I can divide them by 6d because they end in 0. So let's divide by 60 to make this triangle a little bit smaller. So if I divide by 60, I get 1, 4, and c. Okay, so just making sure that my answer key here looks nice. This is still a right triangle with 1, 4, and c. I'm trying to think about how I want to do this. Wait a sec. 60. Where am I getting 60 from? Isn't it 70? It says 70 meters to the south. I'm like, this seems wrong. Yeah, okay. I apologize. I have made a mistake, and if you caught it, you can go ahead and log it. This should be 70. Don't know what I'm saying here. So I had it right maybe before, which means I'm going to divide by something to get these numbers. Oops, I'm going to leave that C. This should be 70, though, because I just wrote it down wrong. This is 70 meters to the south, so this number is 70 meters to the south. So we have a 70 here. I can divide everything by just 10, I think. So let's divide by 10 here. So I get 24, 7, and C. Did we have this problem before? 24 and 7? Yeah, we did. Look at this one. 24, 7, and what? 25. So I'm going to just say C is equal to 5 here. This is a Pythagorean triple from, that was problem 3, from number 3. So C is equal to 25. Okay, so we've got our C is equal to 25. Ooh, better handwriting. And then we just need to solve. Okay, so these guys are kind of large, but we'll try it. So here we go. I'm going to go and say A prime, zoom in here so my handwriting looks better when I zoom back out. A prime plus B prime is equal to C prime. All right, A is 240. 240 times A prime, which was 60. I have to change my colors so they all match so people can follow this. Hold on. A was 60, which was red. A prime, no, A was 240 though. Come on, Mr. Sindel. 240 times A prime, which we did know was 60, which was in red, times 60. And then plus B, we knew was 70. So plus 70 times B prime, which is 0. 70 times 0 is equal to C, which was 25. And then C prime, which we don't know, so I'm just going to call you C prime. All right, colors are all good here. Switching everything to just green. So 240 times 60. Holy moly. Well, 24 is really 6 times 4. And I'm going to remember the 4 for later. So 6 times 6 is 36, and then I have to do 36 times 4. That's, well, 36 times 4 is doubling 36 twice. 36 doubled is 72, double that is 144, so add on some zeros, 144, and then I have to put on 2 zeros, is that right? Yeah, because I have this 0 and this 0, so 144 with 2 zeros. Hopefully you're able to keep up with me with my mental math. Plus 0, thank God. All right, and that's going to be equal to 25C prime, 25C prime. Okay, from here, just needed to divide everything by 25, and I'm going to get C prime is equal to, I'm just going to write this out, 14400 over 25, and then I need to do this problem in my head. So dividing by 25 is similar to dividing by 100 and then multiplying by 4. So dividing by 100, gone and gone. Multiplying by 4 is a double-double. So if I double this, it's 288. If I double that again, that's, what is that? 5, hold on, let me, I need to write this out, otherwise I'm going to make a mistake. This is equal to, I'm going to do an arrow to indicate that I'm going this direction. Wait, I have room underneath, so I can say this is the same thing as, okay, I am going to go to the left, sorry. I'm going to say this is equal to going over 100, and I'm multiplying by 4, and I have 14400, and what I'm doing here showing my work. I'm crossing out the zeros, and this is going to be equal to 288. 288 times 2. I'm just logging my work so I don't make a mistake. Okay, this is the problem. So 88 doubled is 176. So remember that 76 is right here. And 76, this is 576? Is that right? Let me think. 576. For C prime. I think that's right. 576. Wait a second. But does that make sense? Something has gone wrong here. 576, like, this number can't be 576 because that would be crazy fast. That's like 576 meters per second all of a sudden out of just 60. It makes much more sense for this number to be 57.6. So where did we go wrong? Hold on, I've made a mistake and I need to find my mistake. It must have been, I mean, I think it's right here. Let's think here. My logic, I think, was pretty sound. It's 144 with double zeros. Divided by 25 is the same thing as like 4 and 100. They do cross cancel. So it should be 144 times 4. I don't see the mistake. Let's just check here again. 24 times 6 is the same thing as 24 times 3 times 2. That's 144 with the double zeros. I'm not seeing a mistake. 25. Oh my goodness. Oh my goodness, I found it. It's you. You are correct. 25 is correct. But how do we get 25? 25 was dividing by 10. Okay, here. I did it good in the last problem, but really what I have, this is C1, this is C2. What I've solved for is C2. So to get from C2 to C1, what I had to do was I needed to multiply by 10. So C1 is 250, which means this number right here is not 25. It's here. I need to change you to 250. Okay, that makes much more sense. And look at it, 240, 70. This number needs to be way bigger than these two numbers. Okay, this is where my mistake was. I apologize. So 250 comes here, which means I need to move hold on, let me move all of them together. These get moved over, and I say this is 250, and divide by 250, which means really here, I have 576 divided by 10. What's the best way to show my work long ways? I think this might be confusing to people, so let me pretend that this was my new problem, and how would I solve that? The first thing that I would have done is cross this off, and change this to, I could divide the top and bottom by 5. That would make more sense here. If I divide the top and bottom by 5, dividing by 5 is the same thing as getting rid of a 0 and doubling that. So it would be 288. This will be 288 over 5 is equal to C prime. And 288 over 5, I can multiply the top and bottom by 2 again. And this is going to be 576 over 10, or 57.6. Okay, this makes sense. 57.6 for our C prime. And what is that? 57.6 meters per second. So meters per second. And I can finally do my answer. I'm running out of room. I'm just going to do it over here. 57.6 meters per second. I apologize for all the mistakes in that problem, but I just want to show that I'm human too. All right, number 6. Oh boy. Number 6 is, I think number 6 and 7 are both the really hard questions on this one. How do we do these? So let me just read the problem first, get myself situated. A person whose height is 6 feet is walking away from the base of a streetlight. Okay, so I know that this length here, I'm gonna do this in red. This length here is 6 feet. And he's walking away from the base of a streetlight along a straight path, okay, and he's traveling at 4 feet per second. So it's not talking about his shadow, it's just talking about him. So this rate right here is 4, and that's like a prime. So I don't know what I want to call that. For lack of a better variable, that's an x, and it's an x prime because it's moving. So x prime is equal to 4, and just in case you can't see that, let me redo this. This length right here is an x prime is equal to 4. If the height of the street light is 15, so this height of the street lamp right here is 15, what is the rate at which the person's shadow is lengthening? So let's go ahead and call that length right here y, I guess, y prime, and that's what we're looking for. This, I mean, I see the right triangle because, right, this is the right triangle right here, but this is not solved in the traditional way of a right triangle because we're missing this length, the entire length prime. Like, there's so much information on the hypotenuse that is not given that it's kind of impossible to use just normal Pythagorean theorem. And both 6 and 7 are solved in a more traditional way, and this is getting back to the essence of calculus, which is you just set up any equation that works, take its derivative, and solve. So here's what I'm seeing. I'm seeing two triangles. I'm seeing a triangle that is the big triangle, and I'm seeing a triangle that is kind of the smaller triangle on the inside. So the smaller triangle has a length of 6, it has a length of 15 for the big triangle, and I know that to get this entire length down here, again, don't think of calculus, don't think of this x prime, don't think of this y prime. Calculus comes later. Right now I just want just normal numbers. I don't have that number and I don't have that number, but I'm going to call them x and y. So I'm going to say that this tiny length is y, this length was x plus y. Everything right here is purely from geometry, and we're going to apply some calculus to the geometry once we create an equation. So one interesting thing is that these two triangles are similar. How do I know that? The way that I know that is these angles right here, and we're going to take a snapshot in time. So this angle right here is not changing. It's the same angle. This angle and this angle are the same. This right angle and this right angle are the same. By the angle-angle theorem from geometry, you don't need 3 angles because you can always find the third angle by doing 180 minus those 2 angles. By the angle-angle theorem, these two triangles have to be similar. If they're similar, you can set up a proportionality. You can set up a relationship and say, hey, this fraction of 15 over x plus y must be the same fraction as 6 divided by y. And that's exactly what I'm going to set up. So we have similar triangles, and I'm going to say 15 over x plus y, this fraction must be the same fraction as 6 divided by y. And cool, we've set up an equation. This equation is true, and I could solve, but I mean, I have 2 variables, and I can't solve, right? I need 2 equations for 2 variables, and there's no other equation out there. So here's what we're going to do. We're going to take the derivative, but I don't want to take the derivative yet because then I get like weird negative powers from this thing being on the bottom. Let's go ahead and manipulate this equation. I'm going to say, okay, I have this equation. Let's go ahead and multiply this side by x plus y because that will get rid of u and u. But if I multiply the left side by x plus y, multiply the right side by x plus y. And similarly, I don't want to divide by y over here, so let's multiply this side by y, which will cross cancel u and u. And then if I multiply the right side by y, I have to multiply the left side by y. And this is what I get now. I get this cool equation that says, hey, I have 15y on the left, and I have 6x plus 6y on the right. And notice, hey, I have some y terms here and y terms here. Let's make the y terms on the same side. So I'm going to go ahead and subtract 6y, and I'm going to get, what was that, 9y. 9y is equal to 6x, which is much, much easier than saying this thing. And this original red equation was still complex. This is so much easier. We have a valid equation that relates this distance x and this distance y, or that distance y, right? We know that relationship. And I could simplify this a little bit, and here, we might as well. We can divide both sides by 3 and say, hey, divide by 3, and I get 3y is equal to 2x. And from here, we take the derivative. So I'm going to do a magical line here that says, take the derivative. Take the derivative with respect to time, just to animate work. And this thing is going to come up through here and come up out here. And when I take the derivative with respect to time, this is now going to turn into 3y prime is equal to 2x prime. Okay, that's perfect. And I can solve, right? I can come up here and say, hey, I know x prime. X prime is 4. So I'm going to plug in here. I'm going to say 3y prime is equal to 2, and then the x prime was 4. And then that's going to just be, running out of colors, I'm going to go back to red. So I'm going to say 3y, I can say purple. I can say 3y prime is equal to 8, and then finally y prime is equal to 8/3. And there's our answer, 8/3. So we have our final answer, which I'm going to interpret. It's going to be 8/3, and it's going to be a y prime, therefore it's a rate. It's a rate of feet per, there's this, feet per second. So I'm going to say over here, 8/3 feet per second for our final answer, which I will then box. All right. Yeah, that was a really hard question. But again, you set up a relationship. I saw the similar triangles. I set up a relationship. Similar triangles always means a fraction is equal to another fraction. I did some math to make it a lot easier. I took its derivative, and then I solved. All right, I think number 7 is going to be kind of the same thing. Let's try it. So first and foremost, let's set up a picture. I have a person 2 meters tall walking away from a streetlight. Oh my God, it's the same thing. I'm going to be very lazy in my picture. I'm going to do that. Okay. Very, very fancy. So a person is 2 meters tall. So this distance here, or this height here is 2. And the street light is 8 meters above the ground. So this distance here is 8. If the person is walking at a constant rate, so we're going to say that this length now is the rate of x prime. We don't know what rate that is. So I think that's what we're trying to solve for, though. Isn't it saying, yeah, what is the rate in meters per second of the person walking? So we're trying to solve for the x prime. But we do know this. We knew this length now is a shadow. And we're going to call that, just from the last problem, that this length right here is the shadow, and we're going to call that y prime, and we happen to know that that is 4/9, mixing fractions and make it even scarier. And we're trying to find that x prime. So again, I'm going to separate this into 2 triangles to make this a little bit easier to see. I have a, I'm calling that the big triangle, but let me make it an actual big triangle. I have a big triangle, and I have a small triangle. And they should be similar triangles for the reasons stated before. This triangle is 8 and 2 for the heights here. This length here is x plus y, and this length over here is just y. Let's set up our relationship. The relationship here is this. Again, I could say that this divided by this is equal to this divided by this. It doesn't really matter how I set up my triangles, but I typically like my 8 over x plus y, kind of like I did in the last problem. I'm going to say our relationship is that 8 divided by x plus y is the same fraction as 2 divided by y. And then from here, I'm going to solve. And that means I need some room. Give me room, guys. I'm going to multiply this one by x plus y and multiply this by x plus y. Doing that will cancel u and u. And then I'll multiply this side by y to cancel u and u. And that means I need to multiply this side by y. And when I do that, I get this new fancy equation that says 8y is equal to 2x plus 2y. Again, distributing the 2 into each of these, right? And getting all the y's on the same side, I get 6y is equal to 2x, and then dividing both sides by 2 gives me 3y is equal to x. And yet again, we're taking this magical ride where we take the derivative. I'll just say, take the derivative. Yes, with respect to time, but whatever. Okay, I'm going to come up here, take the derivative, and I come out here and I say 3y prime here is equal to x prime, and fill in what we know. What do we know? We knew y prime. Y prime is 4/9, so that comes over here to our y prime, and I say this is 3 times that 4/9 times 4/9, and that's still going to be equaling x prime, and then I just solve. So the 3 and the 9 are going to cross cancel, so the bottom is 3, and this is just going to be 4/3 for our x prime. All right, 4/3 what, though? What are our units here? This one is going to be meters per second. So this one is going to say 4/3 meters per second, and I'm going to say 4/3 meters per second. Final answer, and box it. Cool. Well, that concludes our solutions for homework for AP Calculus AB worksheet 4-9. I know I made a few mistakes in number 5, but there it is. Thanks for watching.